Okay, so today we're doing a lesson over FOIL. So this is our second day of doing double distribution. So remember that when you're multiplying polynomials, the exponents can change. But when you combine like terms, which is adding or subtracting, the exponents do not change. So let's practice example number 1. This one has 2 terms multiplied by 2 terms, so I need to use that double distribution method. So I'm going to start with the 4x squared and multiply it to both terms in the other set of parentheses. So 4x squared times 2x squared gives me 8x to the 4th power. I had 2 x's here multiplied by another 2 here, that's why now I have 4 of them. Now I need to multiply 4x squared times that positive 3. So 4 times 3 gives me a positive 12, and I still have that x squared, so I need to make sure that I bring it down. Now I've got to distribute the negative 1 on this side. So I'm going to make sure I take that negative sign with it. Negative 1 times 2x squared is going to give me a negative 2x squared, and negative 1 multiplied to a positive 3 gives me a negative 3. After this, you need to do some combining like terms. Now the 8x to the 4th power is the only one that has that exponent, so it doesn't have a like term. I can mark it out once I'm done with it, so I know I've already used it. But I can combine 12x squared and negative 2x squared. When I have 12 minus 2, that gives me a positive 10x squared, and then I need to make sure that I bring down the negative 3. Remember that when you do this combining like terms part, the only thing that changes is the number in front, not the exponent attached to your letter. And this is my answer. It goes from highest exponent to lowest exponent, so I'm finished with it. Okay. Same thing on example number 2. So I'm going to start off by distributing 8x squared. So when I multiply it to the 1x in the next set of parentheses, 8 times 1 gives me 8. X squared times another x gives me x cubed. Then I need to multiply the 8x squared times that positive 3 in the other set of parentheses. 8 times 3 gives me a positive 24, and I still have that x squared there, so I need to make sure that I bring it as well. What I also have in the parentheses is a positive 2 in that first set, so now I've got to distribute it to the other set. 2 times 1x gives me a positive 2x. And then 2 times 3 gives me a positive 6. Now what's different about this problem is that now we don't have any like terms to combine at the end. I've got x cubed, x squared, x, and a constant. None of those are like terms, so we are finished. The reason that that happened on this problem, though, was because I started off with x squared and x. They started off with different exponents, so I didn't have like terms. Up here, they both started off with x squared, so I ended up having x squared as my like term. Let's move down to example number 3. Now, if you were tempted to say, okay, my answer is x squared, negative 4 squared gives me a positive 16, so that's my answer, you're wrong. Remember that when you have that exponent on the outside, that means that entire set of parentheses has to be repeated twice. So now it's easier to see that this is actually just another FOIL problem. So I'm going to start with the regular x in front and multiply it to both terms in the other set of parentheses. 1x times 1x gives me 1x squared, and when I multiply 1x times negative 4, that gives me a negative 4x. Now I've got to distribute the second number. It's a negative 4, so take that negative sign with it. Negative 4 times 1x becomes a negative 4x. And negative 4 times another negative 4 gives me that positive 16. Now I am combining the like terms. This gives me x squared, negative 4x minus another negative 4x gives me a negative 8x. And I also have the positive 16. As these two numbers did not cancel each other out, they might be the same number, but they also have the same signs. So this is like saying you're in debt $4, you're in debt another $4, so now you're in debt $8. So example number 4 is the same type of problem. I see that exponent on the outside, so I know that that really means my problem is 2x plus 3 times 2x plus 3. So when you see those exponents right there, the first thing I want you to do is expand. Now you are more than welcome to continue using the double distribution method if you want to, but for some of these problems I want to show you guys the box method. So since I have 2 terms times 2 terms, I have a 2 by 2 box. And I'm just going to put these numbers on the side. I've got 2x plus 3 and 2x plus 3. Whenever they have a symbol in front of them, like a plus sign, keep that with the number that it was with. This just makes it a little bit easier for me to see what's actually being multiplied together. In this first box, I've got 2x times 2x, so that gives me 4x squareds. And the next box, I've got a 2x being multiplied by a positive 3, so that's positive 6x. Same thing right here, I've got positive 3 times a positive 2x, that is 6x. And in the last box, I've got positive 3 times another positive 3, which is 9. After you do that, you still need to combine the like terms. I've got 4x squared out there in the front, but the like terms are 6x and 6x. When you add those together, it gives you a positive 12x. And then don't forget about the positive 9 right here. Make sure you put a plus sign because it is a positive number. Okay. All right. So for example number 4, I'm going to go back to using the FOIL method. I am going to have a little bit of a different situation happen whenever we try to combine like terms, so I'm just giving you a heads up. Start by multiplying the x to both terms in the other set of parentheses. 1x times 1x becomes 1x squared. 1x times that negative 9 right there gives us a negative 9x. Then I've got to distribute the positive 9 here. 9 times x is a positive 9x. And then 9 times negative 9 over here becomes negative 81. This time, when you combine like terms, I've got a positive 9x and a negative 9x. Well, guys, they have the same number and opposite signs, just like when we did elimination, so they cancel each other out. Another way to think about it, if I've got negative $9, and then I add $9 to that, well, now I've got $0. I'm back at square one. So when you combine those like terms, they canceled out. Once they've canceled, you don't put any regular x's at all. You just bring down what's remaining, the x squared and the negative 81. Now, the reason that happened to you in this problem, these sets of parentheses are almost the same thing, but one's got a plus and one's got a minus. So when they have opposite signs like that, they are going to cancel, but if they have the same sign, like on example number 4, they are not going to cancel in the middle. Okay, so let's do the same thing on example number 5, but this time I want to show you using the box method. Okay, so for the first problem, I've got 5x plus 2, and it didn't matter if you put it on the top or the side. And the next one has a 5x and a negative 2. Make sure you keep that negative sign with the 2. It's a little bit easier for me to see now that exactly what I'm multiplying. 5x times 5x in that first box gives me 25x squared, because there was 2 of them. Over here, I've got 5x times a positive 2, which is a positive 10x. This third box, negative 2 times 5x becomes a negative 10x. And the very last one multiplies negative 2 and positive 2. That gives me a negative 4. So now we've got to combine like terms. I still have 25x squared in the front. And when I do negative 10x plus 10x, they cancel. And I still have that minus 4. So once again, the reason that happened, I was able to cancel something out in the middle, is because I basically had the same set of parentheses, except one was positive, one was negative. Okay. All right. Now we're going to change things up a little bit. Now we are multiplying a binomial, which means it's got 2 terms in its set of parentheses, times a trinomial, which is 1, 2, 3 terms. Well, this is the same thing as double distribution. So I'm going to take the 2x in the first set of parentheses, but I've got to make sure I multiply it to all 3 terms in the second set. So I'm going to start. 2x times that 4x squared gives me 8x cubed. I had 1x here times 2x's here. That's why I've got 3 of them now. Then I've got to distribute. 2x times a negative 3x. 2 times negative 3 gives me the negative 6. And when I have x times x, that one is x squared. The next one, I'm multiplying 2x times that negative 2 all the way over there. 2 times negative 2 gives me a negative 4, and I did have an x right here, so I need to make sure that I bring that one down as well. So that took care of distributing the 2x. Now I've got to deal with the positive 1, and I have to do the same thing. Multiply it to all three terms. 1 times 4 still gives me a positive 4x squared. Then I'm multiplying 1 times a negative 3x, that's still negative 3x. And positive 1 times a negative 2 gives me negative 2. Now that we've taken care of the double distribution part, we've got to worry about combining the like terms. It's a bigger problem now, so you've got to make sure that you're keeping track of what you used and what you haven't used. 8x cubed, that one has the highest exponent, and it's the only one that's x cubed, so it goes first. So I'm going to mark it out now. But I do have a negative 6x squared and a positive 4x squared. Well, negative 6 plus 4 gives me negative 2, and I'm going to leave it as an x squared. You don't change the exponents when you combine like terms. The next two, I've got a negative 4x and a negative 3x. Well, negative 4 minus 3 ends up giving me negative 7x's, and now all I need to do is make sure that I bring down that negative 2. So this is my final answer for example number 6. Now the very last problem, I'm going to show you, it's once again another binomial times a trinomial, so it's going to be one like this. But I'm going to show you how to do this problem using the box method. So since I've got a 2 by 3 problem, I need to make sure that my box is a 2 by 3 box. So I'm going to make this side 2, and I'm going to make the other side 3. So when I'm filling this in, x minus 3 has to go on the side with the two boxes, so I've got x and a negative 3. For the other side, I'm going to separate each one out a little bit. I've got 2x squared for the first term, a negative x for the second, and then the positive 4 at the end. So this method really helps you whenever you've got these longer problems. I'm going to multiply. 2x squared times x for this first box is 2x cubed. Then I multiply negative x times x. Well, guys, remember, the imaginary number in front is 1 right here. So 1 times negative 1 is negative 1, and x times x is x squared. Okay. I'm also multiplying this 1x times 4. 1 times 4 still gives me 4, and then don't forget to put the x right there. Now you've got to multiply the negative 3 to each one of those terms. So negative 3 times 2 gives me the negative 6, and I still need to make sure that I bring down that x squared. Negative 3 times a negative 1 becomes a positive 3, and then don't forget about the x that's right there. And then for the last box, negative 3 times 4 ends up giving me a negative 12. Now I just need to worry about combining the like terms. I do have 2x cubed, and that's the only one that's got that third exponent, so I'm going to mark it out now. I can combine negative 6x squared and negative 1x squared. So if I'm in debt $6 and then I'm in debt another $1, I now owe you $7. So I've got negative 7x squared. If you need to type that into the calculator, you can do it two ways. You can say, all right, I've got negative 6 and I'm subtracting 1 more from it. That's how I got negative 7. Or, since we are combining like terms, combining means to add, you've got a negative 6 plus a negative 1 for those two terms. It still gives you the same answer either way. Okay. I also need to combine the rest of it. I've got a positive 3x and a positive 4x. Those two add together to give me positive 7x's. Don't change the exponent right there. And then just bring down your negative 12. Now you have your final answer.